All right, guys, so in this video, I'm going to go through these problems here. I'm going to take the even ones again. So I'm looking at the top of the page, page 128 here. And I'm going to start question number 36. Take 36, 38, 40, a few like that. All right, so it says in problems 35 through 64, graph each function using the techniques of shifting, compressing, stretching, and or reflecting. Start with a graph of the basic function, for example, y equals x squared, and show all stages. Verify your results using a graphing calculator. Well, I'm going to talk you through it. I'm going to graph it here on Desmos. See, I already have a graph up. I'm going to graph it, and I'm going to talk you through how the points shift from our basic function to with the transformations that we make. So with question number 36, we are given the function x squared plus 4. So my basic function here is going to be x squared. So I'll take x squared. We know that that is going to be parabola centered on the origin right here. It will have points 1, 1, 2, 4, etc. And I want x squared plus 4. Well, that's going to shift my graph up 4 places. So I'm actually just going to put it here as a separate function. That's x squared plus 4. So there's my graph, x squared plus 4. Now, if I have graphing paper and I want to graph this, well, from my original function, I know that I have, like I say, I have 0, 0, I have 1, 1, minus 1, 1, 2, 4, minus 2, 4, etc. The x squared plus 4 graph is going to have the points x, y that are on our original function, x squared, but the y values of those points, the y values of those coordinates are going to increase by 4. That is to say, if I have a point 0, 0, just minimize this, that out, hide that. If I have the point 0, 0 here, then on my original function, then the y value of that coordinate, in this case 0, is going to increase by 4. And so I'm going to have 0, 4 on my new graph, and that's that one right there. That's the vertex of a new graph. If I have the point, let's say 1, 1, which is right here, there, 1, 1 on my original function, then the y coordinate, which is 1, the y value of the coordinate, which is 1, is going to increase by 4. And so I should have the point 1, 5 on my new function, and there it is, 1, 5. Similarly, one more example, if I have 2, 4 right here, 2, 4, then I should have the point 2, 9 on my new function, and that is, zoom out a little bit. Did I say 2, 4? I should have meant 2, 8, of course. 4 plus 4, apologize. So 2, 8, which is right there, 2, 8, not 2, 9, 2, 8, of course. And so all that is happening is that every point x, y that is an element of my original function x squared, well, my new function x squared plus 4 will contain the points x, comma, y plus 4. All right, so that's that one. So if I go back to my questions here, I'll look at question number 38. So question number 38 is x cubed minus 1. So we're asked to graph x cubed minus 1. Well, it would be useful to see what x cubed looks like. Excuse me, x cubed looks like. X cubed looks like that. It's my x cubed function. Looks like that. Very this elongated shape like so. Has a domain from negative infinity to positive infinity and a range of negative infinity to positive infinity. So that's our function. And the question asks us to graph x cubed minus 1. Well, much like the previous problem, all that's going to happen here is that my graph is going to shift down one place. We know that. So minus 1, x cubed minus 1, is just going to shift my graph down one place. And so the y values, again, are going to, in this case, be subtracted by 1. So at any point that was on my original function, maybe I'll just put in my original function again. That's x cubed. It's right there. So my original function has the point 0, 0. My new function will have the point 0, negative 1. So my y value has decreased by 1. It's the effect of that minus 1. And that happens with every point that's on my original function. The y value of the coordinate will decrease by 1. And so that is how we would find our new function. Just simply step down there by 1. All right, moving on. I have here the square root of x plus 1. All right, well, let's have a look at the square root of x to start. Square root of x. That's what the function of the square root of x looks like. As you can see, its domain is from 0 to infinity. It includes no negative numbers because of that square root sign. And its range is also from 0 to infinity. Right? There's no negative values in its range. So it continues out there like so. We want square root of x plus 1. Right here, x plus 1. Well, that's replacing x with x plus 1, and that's going to have the effect of shifting my graph one place to the left in the negative direction. X plus 1 shifts it one place to the left. And so then the question becomes, well, what happens to my coordinates? Well, again, it's probably easier for me to just put in both functions so that we can see what's happened. 0, 0 is on my original function. My new function has the coordinate points that were on my original function. It has their x values decreased by 1 because it has shifted in the negative x direction. So if 0, 0 is on my original function, then minus 1, 0 will be on my new function. 4, 2, for example, will be part of my original function. This is the square root of x. 4, 2 will be on my original function. And so we would expect that 3, 2, that is 4 minus 1, which is 3, 3, 2 will be on my new function. And sure enough, it is right there. 3, 2 is on my new function. 9, 3 would be on my original function right here. 9, 3. And so we would expect that 8, 3. Subtract 1 from my x coordinate. It's 9. And so 8, 3, which is right there. Let's do it. Come on. 8, 3. Right there. That's on my new function. And so it has just, like I say, shifted over 1. And that's how we would go about graphing it. You can easily find some of these points that are on the original function. Well, all you're going to do is subtract 1 from the x coordinate. All right, I'll do a couple more. Let's try question number 42. Question number 42, f of x is equal to x plus 2 all cubed minus 3. So my basic function here again is the cubic function. So it's x cubed. That's my basic function, x, cubed. Seen this before now. And what has happened to my cubic function? Well, I've replaced x in my original function with x plus 2. That's going to shift my function 2 places to the left. So that's going to shift my function 2 places to the left. So let me put it down here. That is x plus 2 cubed. Oops, cubed. That shifts it 2 places to the left. And so I subtract 3. This minus 3 from my function is going to translate it vertically downwards. So this minus 3 will shift my function downwards. Okay, so what has happened? Well, this time 2 things have happened. Something has happened to my x coordinate and my y coordinate from my original function. So if I take, again, I'll just go with 0, 0. 0, 0 is part of my original function. What happens with this plus 2? This plus 2 shifts my graph in the negative x direction. And so my 0 here from my original function, the 0x value will have 2 subtracted from it because it's shifted 2 in the negative x direction. So it's this value here of x will become negative 2. The y value won't change with that horizontal translation, but it will change with the vertical translation. And so this minus 3 here which translates my my function downwards, will cause my y value of 0 to have 3 subtracted from it. So it'll be 0 minus 3. And so we would expect that this point then will be, this point here has been shifted over 2 to -2 and then shifted down here. And that is, apologize, that is this point right here, which is right there, -2, -3. -2, -3. So that is this point here. And that happens for every single point on my original function. And so, for example, and just to take one more example, 1, 1 is on my original function. X is 1. It's there. Hard to get it exactly. Nice. There it is, 1, 1. And so what has happened to this point 1, 1? It will have its x value reduced by 2, so it'll go from 1 to -1, and it will have its y value of 1 reduced by 3, so it will go from 1 to -2. So I would expect that the point -1, -2 will be part of my new graph. Let's see if I can find that. -1, -2 is about there. Let's see. There it is, -1, -2. And so if you can find a few points on your original function, you now know what has happened to those points. You now know what this effect of this +2 and this -3 has done to those points. All right, let's take one more. I'll go again with the even problem. So I'll go with question number 44, which is 1/2 times the square root of x. So I'll go here. I'll take this time the square root of x. That is the square root of x, which is this function right here. And I want to take 1/2 of the square root of x. Well, let me put that down here. So that's going to be 1/2 times the square root of x. So that is this one here. And so what is the effect of this 1/2? Well, it is to vertically compress. So it is a dilation of my function. It is to vertically compress my function by a factor here of 1/2. What this means is that any point that was on my original function, so for example, again, 4/2 is on my original function, root x. The y values will be multiplied by whatever this constant out here in front is, in this case, 1/2. And so the point 4/2, which is an element of my original function, that 2 will be multiplied by 1/2. 1/2 of 2 is 1. And so I would expect that the point 4,1 will be on the function 1/2 root x. Let's see, there it is. We also have, of course, again, 9,3 right there. 9,3 is on my original function. X is 9. Then the function is the square root of 9, which is 3. And so I would expect that my y value, in this case 3, will be multiplied by 1/2. 1/2 of 3 is 3/2, or 1.5. And so I would expect that this here is, sure enough, 9, 1.5. And that happens for every single point. You go 16,4 on my original function will become 16,2. Only the y values have changed. Okay, that is how I will go through a few more of these problems in a later video. That's just to give you an idea of how you'd go about graphing these. You'd graph your original function, find a few points on that original function, and then by noting what has been done to your original function, has it been translated upwards or downwards, has it been dilated, has it been reflected, you can then work out points on your new function and graph it pretty quickly that way. Okay, thank you very much.